So my talk is keep it simple, stupid. This is really meta when it comes to development because this is really the process around how you develop, how you start a project from point zero and get it to the end. And it's really about designing code for maintainability and collaboration. Very rarely are we the only developer who ever works on something. And especially if you work for a large organization, a lot of times the code you're working on was not necessarily written by you and will be maintained and written by people beyond. So all of these things, go into all of that. So what I'm going to prove today is that you're paid to solve problems and not write code. I feel like this is common wisdom if you've been around for a while, but it really bears repeating. And I think there's some things that once we start getting coding, we kind of miss on that. Another one is for every 1 hour spent planning, you save 10 hours of execution. Now that sounds crazy, but as I'll talk about a little bit later and show in examples, you cannot overplan, and you truly can cut development times almost in half by just spending more time planning. And the last one is less is more. So a bit about myself. I've been in software development for over 25 years. I have programmed in almost every language professionally. I've touched a whole bunch of languages just for fun. I've spent 5 years plus on the W3C digital publishing group, so I have experience in standards. I've worked for startups, mid-sized companies, and large-sized companies, and through the years have been part of and designed and developed over 10 applications from the idea phase to reality. So not just coming in and maintaining projects. I've been part of 4 major large-scale rewrites. I, through much of my career, have been a project firefighter, which basically is whenever a project is failing, I get thrown into it to try and fix it. So I have come into a lot of messes, and through that, I've learned kind of how to clean up and how to prevent those messes. So that's really what I'm trying to get out to you. And I am a hands-on development manager, a coach, and a speaker. Now, a little bit more about me. I am not a 10x programmer. My code is simple. My code is elegant and it works. But I have met a few people that we call those 10x programmers. That's not me. I'm just kind of some regular average guy who's just spent a lot of time doing this sort of stuff. I've over-engineered at least 50% of my projects, so I've made enough mistakes that I can now talk about them and hopefully help other people prevent them. I've accidentally dropped a table in prod. So if you've done that, then you are in good company. I've written poor commit messages. I have edited code directly in prod. And I've spent hours trying to optimize something that wasn't even a performance issue. So, I've seen the highs and I've seen the lows. So this should be very familiar to people. This is kind of that 1 year project. You can squeeze it if you want to make it a 6 year, but when you're working for a mid to large size company, you'll see this. And usually it starts with the business giving you a set of requirements. We need an application that does X, Y, Z, A, B, C, whatever. And they hand it to the development team. And at that point, the development team has about 1 month for planning. And then they have to start showing something. So it's off to the races. You develop for 10 months, and then you've got 1 month for QA and user acceptance testing, and then you launch. And this is just generally accepted. Oh, it's going to take 12 months. What I have found is that if you plan, then you can make it an 8-month project. So what would have been 12 months is now 8 months. And that 8 months can often even start earlier. And really, because planning happens as part of requirements, and it's really about a meshing of the business and the technology side at the same time. So what goes into the planning phase? The first is understanding the requirements. Too many times the requirements are just kind of handed over. And like I mean, for anyone who's old enough to remember the waterfall model and getting their BRD documents and just these massive 50-page things. Um, as much as it was great to get specifications, a lot of times developers, the ones writing the code, didn't understand what problem they were trying to solve. So you would get people who would spend time developing something that needed to be reworked. So really, day one is just being part of the business, talking with the business to understand the requirements. The second one, and this is important, evaluate many code framework options. Oftentimes, what people say, well, I've laid code, I've started writing code, I'm just going to go. So you pick React as a front end framework and you run with it. You pick, Tailwind, you pick whatever. And at the end of the day, every framework has positives and every framework has negatives. And you need to understand what framework will suit your full needs best. And the only way to do that is to evaluate more than one. So if you're spinning up a React project, you should also be spinning up a Next project, maybe spin up a Vue project. Your developers, during the time where requirements are being gathered, should be playing with different frameworks, trying to understand in a bigger picture what's the right solution and what's the right framework. Having dialogue with your stakeholders. So the technology team needs to be a stakeholder. They need to have investment in the success of the application, but they also need to be available early on and part of that discussion. Now, this is what's called this is also known as the expert trap. So how many times have we been asked a question and the first option we come up with all of a sudden becomes the best option and the only solution, and we run with that? It's like, hey, we need a database. MySQL. Let's just go with MySQL. So, all of a sudden now we're using MySQL, but we didn't stop and say, do we need a SQL database? Do we actually need a vector database? Do we need something that's more NoSQL? Do we need... So just because we have an option that sounds good, don't stop and actually spend more time determining if that answer is the right answer or the best answer, because there's multiple right answers. And the last thing that happens should be planning should be out-of-the-box solutions. As coders, we like to solve problems with code. There's a phrase I use often: when all you have is a hammer, everything looks like a nail. And if you try and nail a screw into a piece of wood, it doesn't work very well. It works. You can get the screw in there. Trust me. As a failed carpenter, I can tell you can do it. But so much development time can be saved by buying software. And I know sometimes, like, the business, like I'll be in a situation where I'll say, there's a piece of software that'll cost us $1,000. And they'll go, whoa, that's crazy. And I'm like, our developers cost more than $1,000 a week. So what I'm saying here is you can spend a whole month developing something, or we can buy it for $1,000. And all of a sudden it's like, well, yeah, okay, that's a whole lot cheaper. So out-of-the-box solutions, if they work, are a huge way to save time and money. And then understanding roughly what you're expecting now, tomorrow, and what requirements are your wish list items. All right, you are not paid to code. You are paid to solve problems. So I'm going to repeat that. If the technology group, if you're expected to solve a content management system, you are not paid to write thousands of lines of code. You're paid to solve the content management system. So if WordPress solves your needs, you are of more value choosing WordPress and maintaining that than you are writing your own content management system, assuming that works. All right, 90% of apps are over-engineered. If you ever work on an app that you feel like, you know what, this is right-sized, it's perfect, There's nothing in here that's unnecessary. I'd be surprised. It shocks me that, I mean, any front end application that uses React uses a bunch of different node modules, and then you add it all up and it's 600 megabytes for a 2-page application. It's over engineered. When you over engineer code, you frustrate yourself. You distract future you from solving new problems. You increase the difficulty of new development for future you. And you're embarrassing future you when you have to explain why you have to rewrite code that you wrote in the past. So love yourself, current you, and future you. All right, so what are the phases of development? So when I think of projects, I mean, they really break down into three main parts of a life cycle. The first is the proof of concept. So if you work in a startup, pretty much everything you're doing is proof of concept. And a proof of concept is a great way to show that something works. So a lot of people are building proof of concepts on top of things like OpenAI. It's like, all right, I have something, it throws a prompt in there, gets the response, and displays it. And it's a great proof of concept, but it doesn't scale. It often, can't go beyond what ChatGPT can do. And you really, there's limitations. So proof of concept is usually small, limited in scope. It does one thing, it does it really well, and it's just meant to see, is this worth developing more? Where I see a lot of businesses make bad decisions is then they go into phase 2, which is boil the ocean. And that's when you take a proof of concept and you try and blow it up. So it's like, okay, great, this does A, but we want B, C, D, and E. And while we're at it, it's got to do F and G. It's got to handle 1 million concurrent users. It's got to have this and this and this. And this is, ChatGPT is new, so it's got to integrate ChatGPT. And it also has to have its own chatbot, but then it's got to, and your requirements get out of control, and all of that happens. And oftentimes, especially if your proof of concept is good, that actually gets approved. And you have this crazy idea, and then the reality sets in of how much work it's going to be once you've got a few launches, behind you. And then you wait, we have a code base that's unattainable. It's just a mess. It's spaghetti. So we have to do it all over again. And then you go into phase 3, which is actually what your customer wants. And in most cases, that's a limited feature set, limited requirements, and hopefully a simple enough architecture that you can keep going. So by planning, the idea is to skip phase 2 altogether and go right from proof of concept into what your customer wants. All right, so some stories. So a startup that I worked at several years ago, 15-ish years ago. So we started with a proof of concept. We took a pre-built software. It was, I think, roughly $500 template, and it was a DVD rental service. So we were going to be a book rental service. So we were kind of like Netflix, but for books. And the DVD rental, it worked reasonably well. We were able to, make it work with ISBNs as opposed to, the EANs on a DVD. We were able to get it with work with book data. So ultimately, we saved a whole bunch of time because we used something that existed. It took 1 developer and 2 interns about 3 months to customize this and launch this. So for a proof of concept, that was really solid. But we had performance issues. We couldn't grow. We couldn't extend it. There was some security concerns. So at the end of the day, as a proof of concept, it was great, but we had to rewrite it. So when we rewrote it, there was a fancy new PHP framework that had just come out. So we decided to apply that because the lead designer at the time, wanted to do the bleeding edge of everything. We also tried to do warehouse management, inventory management, purchasing system. We tried to do everything. So really, we entered boil the ocean. The project was good, but it got over-engineered. And we very quickly found that PHP framework ended up biting us in the butt. it was not new enough, or it was not out long enough for it to kind of get through its issues. It was going to take too long to report every bug. It wasn't right. And about a year in, 9 months in, we had to rewrite it from scratch. And this time we just wrote it in straight PHP. We wrote a very small, lightweight framework on top of it that we wrote in house that is super simple. An intern could learn it in a day or two. And it made our development simple. And we did manage to get warehouse and inventory management in, and we got a few other things, but we did it on a much smaller scale because we weren't Netflix. And it took a little longer to develop, but we had a much more robust system that the reality was it actually ran itself. It handled customer service almost completely automatically. It handled purchasing almost completely automatically. So we were able to take 12 workers and bring it down to 7. So it just really was all about planning in that stage. So I talked about what we learned. So the frameworks were just not there. You have to really design for what you need. Oftentimes we get so excited, we want to do everything, we want to boil the ocean, and you really gotta slim that down. We cut a lot of corners in the beginning, and every corner we cut bit us. And I'm just going to keep reiterating: plan, plan, plan. All right. So to answer hopefully a question that might be in your mind, where do developers and requirements sit? When you work for a startup and you've got 8 people in the company, you're all talking to each other. You all know what's going on. You're probably kind of already part of that. If you're a one-person team, you're everything. This isn't for you. When you work for a mid or large size company, there can be a business side and a tech side that don't talk to each other very well. The business side sends requirements, tech side writes the software. So what I have found works really well is you have to break those silos down. You have to bring the tech side over to the business, and you have to make sure they understand the KPIs. KPI is a key performance indicator. So let's say you're an e-commerce website. Your conversion rate, your add to cart rate is going to be a key performance indicator. Your checkout completion rate, so the from add to cart to checkout. So there's going to be certain items that are going to be really important. And knowing what those are will help you as a developer, because if you know you need to make something easier, then when you're developing, you're going to think, does this make it easier? Because sometimes requirements get confusing. You have to know who your personas are. You have to know who is using your site. What is their motivations? What do they want out of your site? And are you delivering that? You may not be a design expert and know if a green button or a blue button or a red button is going to be more successful. But if you know that your target audience is over the age of 60 and you're using 8-point font, you should know that that is not going to work. And as I was saying, developers must be key stakeholders. The developers need to be part of the requirements process, even if it's just to talk through what possible solutions are. And I think what's critical there is oftentimes the business will want, let's say, 3 features. So let's say a search engine. So we want a search engine, and let's say, so I work in the book world. We want a search engine. We want to be able to search on title. We want to be able to search on author, and we want to be able to search on themes. So you talk through this and you're like, well, title's super easy because we have the data, it exists. Authors, super easy. We have that data, we can do it. Themes, I don't know what you mean by a theme. And so now you can have a discussion and you can talk to the business about what data does exist, what data doesn't exist, how much time it will take. Because if you're there early in the process, you have a chance to say, well, title author is easy. It'll take us less than a week. Theme is going to be hard. It's going to take us a month. And the business can say, you know what? You're right. Theme is not worth 1 month of effort. So you've cut an entire month off of your dev timeline because you had a single conversation. Or the conversation could go, here's the data we do have. So instead of theme, can we change it to keywords? And they're like, yeah, keywords is great. So you're having that discussion up front, as opposed to once the business has committed and like, here's our timeline, here's what we want. And then you come back and say, well, it's going to take a month and 2 weeks, and it's just, so you're extending your timeline when it may not be necessary. All right. So another project that I've, went on that had a similar type process was phase A was proof of concept. It was a single developer. This was a startup that I had, and um, every day was a new requirement. So every day was just heaping on more and more and more code. We got through 2 years of development. It got us through our 2 rounds of funding. It got us to acquisition. But I'm proud of what the code did, but I'm not proud of the code. The code was a mess. I like to say it was held together with duct tape and safety pins. It was not scalable, but it did what it was supposed to do. So once we got acquired, they had a really tight deadline to try and get us to a certain revenue number. So instead of saying, well, now you have this proof of concept that we need to throw away and rewrite, they said, you have to just keep adding on to it. And you have to get all of the legal requirements, all of everything else that we had neglected. So we just kept building and it became a behemoth. So the boil the ocean stage was just slapping on code after code after code. And it became unmaintainable. And it was, we were hitting lots of performance issues because scalability wasn't in mind. It hit that point where we had to rewrite everything. Now, there was a lot of decisions made in that rewrite that I bring this up because I think it's a great learning lesson. So we decided to go and try and be leaders and go into a microservices architecture. So the design here, and where we failed to plan enough, was we said, we're going to take this one service and we're going to break it into 15 smaller services so that anyone else in the company, this is a large company of over $1 billion a year in revenue, so everyone can use every little piece. So if anyone wants book data, they've got it. If anyone wants this, they've got it. If anyone wants this. So we designed with that in mind. And the reality was no one in the company used any of the microservices. And it was because the corporate culture was not that anyone would use a microservice. Like we weren't Amazon back in the early 2000s saying everything's a microservice, you have to do this. It was us in a little project thinking too big, and again, trying to boil the ocean. And when you talk about maintainability, each service had its own repository. So we now had 19 total repositories. It was confusing. Now the code itself is kind of nice, but we tried to do too much, and it cost us. We could have saved 2 to 3 months had we just not done that. So I talked about this. Microservices is a large scale organization decision. If you're told to do something in microservices, just ask like why. Like, does this need to be a microservice? Microservices are great. And if someone's going to use them as such, awesome. But otherwise, decoupling all your code, so you have to have projects that reference, you have to have maybe a NuGet package with all your object models. And it's just, it's excessive if you don't need it. We did test-driven development. That worked really well. I wish we had tested it out a little bit more in the front. The other thing that was great to learn, because I've been doing this for 25 years, is high quality code is almost infinitely scalable. So I come from the days where you can have a script that like a single server can only run a few hundred copies of it at a time. So you need to have replication, and so every CPU cycle mattered. In today's world of cloud computing, it almost doesn't matter. Like we set up this microservices to be able to scale up to 50 instances, and we would have 2 was our maximum we ever hit. And we were supporting 200 to 300,000 users a day. So it was like performance was never an issue. Also, if you work for a large or medium-sized company, security and compliance needs to be part of your requirements and planning. The amount of time we spent getting 3/4 the way through something and legal would come in and tell us it had to work differently. Again, plan, plan, plan. All right, for every 1 hour spent planning, you save 10 hours of development. I started out as a developer, and I'm going to speak for myself, but I know I'm not alone. I love to kind of dive in and code. I love to see success early. I love to see things move. And planning is hard for me. Like I have to tell myself, stop and plan. But that said, and I spend more time planning. When you think you're done planning, plan some more. And it organizationally, it can be hard because it's like you've spent 2 weeks. What have you done? And it's like I wrote 2 pages in a planning document. It doesn't sound like a lot. But if it's like I've evaluated 4 different frameworks, I've thought about our data model and tweaked it 1,700 times because I found this one thing, and like those things are going to save you months of effort. So plan, plan, plan. I have one more project that I kind of want to talk a little bit about, but I think I'll come back to that if I have time. 90% of apps are over-engineered. So I'm going to say this, again, this is not a duplicate, showing again for effort. I have not seen enough planning, and especially the planning where the business and the tech side are really engaging early on. You'll save so much time down the road by planning and not over-engineering. All right. And again, you are paid to solve problems, not to write code. If you are asked to build an e-commerce website because you want to sell handmade crafts, if you're not using Shopify or Etsy, you're making a bad financial decision. With a little asterisk there, yes, if you have some crazy new technique or something else going on, fine. The cost that Etsy or Shopify is going to take from your transaction is not anywhere close to the cost of developing, maintaining, and dealing with all the other hassles. So as a technologist, as a technology manager, it's your job to understand what's the problem you're trying to solve and how can you solve it, not necessarily how can you solve it with code. All right, so design is for tomorrow and not 10 years from now, especially with how fast AI is moving, with how fast cloud computing is moving. If you're designing a solution that's going to work for 10 years, it's probably not. And one of the previous presentations showed a wonderful quote about being fluid. And the reality is technology is changing a lot, and the best thing you can be is nimble and small and fluid so that you can adapt to whatever is coming up. So the build versus buy, if you have to buy a new piece of software every year, it's probably still cheaper than hiring a developer to maintain and update a piece of software. The middle point has been called out to me is really important. Developers are expensive, infrastructure is cheap. So what that kind of means is that so this goes back to build versus buy. If there's a solution out there that costs $250, that's, in many cases, less than a developer's day's worth of effort. Chances are a $250 piece of software is going to take a lot more than a day to manage or maintain. So, where possible, buy things that are pre-made. Also with infrastructure, optimizing a database so that you only need one instance of a database versus two because you don't want replication or things like that. You can replicate a database for 250, $500 a month in the cloud. A developer costs a lot more than that. So spending a month trying to optimize code is usually not worth it when you can just throw hardware at it. Also, easy to read code over performance, because a senior developer who writes code that only a senior developer can edit is going to cost you time when that senior developer is gone and you have a mid or a junior spending a month trying to figure out what that code did. So that's where the simplification process comes in. That's where planning comes in, because the amount of times I've seen a project where they chose some esoteric package or esoteric framework that some senior developer who probably contributed to that framework did and chose, and it may be elegant, it may be quick, it may be super performant, but you can't get other developers to work in that environment. So it's short-term decisions that hurt the long term. The last point here is momentum is hard to break. If you get a developer, group of developers who start working in React, they're not going to want to change. They're not going to want to go to Angular. So once you kind of commit to something, it's very hard to get people to want to redo the same work they've done in something else. So that's where, in that planning and requirements, it's really important to give your developers like a set deadline. Hey, you've got 1 week. Install Vue, install React, install Angular, and then you tell me which one you think is best. And then you evaluate and make your decision, things like that. Bad decisions are made with good intentions. No one on the business side wants to hurt developers. So when they make a request, they're not doing it thinking, oh, this is going to be hard for the developers, or this is going to make someone's life difficult. They're just thinking, this is what we want. And oftentimes, again, choosing like a front end framework, you'll decide, well, let's go with React because I have 2 React developers right now. If you need SEO, you need to go with Next, which, yes, is sort of React, but you need to make sure that you're making the decisions correctly. Even though you might have good intentions, you still might make bad decisions. All right, so let's go back to the planning phase, because this is really where I think, this is what I think is the meat and potatoes. So understand the requirements. Obviously, the earlier you can be part of that process, the better. But really what it comes down to is making sure that every developer who's writing code understands why they're doing what they're doing and what the requirements really mean. Evaluate many code framework options if you even need a framework. Don't stop at the first one. And the first good answer is not always the best answer. Have dialogue with your stakeholders, constantly be talking. If you have a big development team, let's say you have 15 developers, 1 or 2 dev managers, and then a director, make sure that the director understands everything. And the director then communicates to the manager, make sure the managers understand things, and the managers can make sure that the developers understand things. But everyone has to understand that. Again, the best option is not always the first one. Good option is good, best option is best. And research out-of-the-box solutions. Again, you are not paid to write code, you are paid to solve problems. Understand the current, future, and wish list. I will also differentiate here where I didn't before. So the current requirements is what you need today. So if you were developing PayPal, it's like the current requirements is people need to be able to transfer money to other people. Great. Future requirement might be we need to support contactless payment. So we need to do all the taps. A wish list requirement might be we want biometric protections. So understanding that it's like, okay, that's a big one. We need to keep an eye out. and we need to be aware of it, but it's not something we need to design a whole system to be able to work with it, because it might be too big, it might be out of scope. We might not have the technology available today to be able to do it in a reasonable way. All right, so the key takeaways: repeat, repeat, repeat. You are paid to solve problems, not to write code. For every 1 hour you spend planning, you save 10 hours of execution, and less is more. So unless you have the weird job where you're paid per line of code, writing less code that solves the problem still is going to be more valuable to yourself and the other people on your team, and you should work towards that. All right, so thank you. I think we have some time for questions. If not, I will go back to my other story.